So a quote from Gartner here, it's basically saying that, it was once theoretical. People would talk about the possibility of your supply chain and your open source libraries being compromised, but today we're just seeing it over and over. So we're going to have a look at a few of those. Just another quick quote here from a lot of prominent individuals saying that if you don't have some sort of defences in for your supply chain, you're going to have issues. In America, the US government has even put out an executive order directive for improving the supply chain security as one of the measures, to take care of your overall posture. So how and why are your supply chains at risk? First of all, what is the supply chain? And there's very strong parallels between traditional supply chains and your software supply chains. So you take your parts, you build them into the whole, and then you ship them out and deploy them to the users. And of course, during that process, there's a number of points where you're vulnerable. So SALSA, no, not this one. The supply chain levels for software artifacts is a consortium, some of the biggest players like Google and Intel, Linux. And so they're aiming to identify and regulate the different stages of the supply chain so you can prevent tampering, improve your integrity, and secure your packages. So we can see here the steps in the supply chain that they've put together. And looking at this, you can see the source threats and the build threats. Now, these are the traditional areas that everybody's been looking at. There's lots of established methodologies here for you to lock these down. So, enforcing two-factor authentication on your GitHub, hardening your servers, preventing access, that sort of thing. Things that everybody's been doing for years now. Where the real issue is starting to be seen is with your dependencies, with the open source software that everybody's using. So everybody's using open source. And up to 90% of the code in your apps is actually coming from open source. So, developers love open source because it's fast. Nobody wants to have to reinvent the wheel every single time. It's just so much easier to take a proven open source solution and integrate it into your code and just keep moving on with what you need to do. But the problem here is the dependencies of the dependencies. The developers of the open source software also love open source code. You ask for a single package and you install that into your code, and that's what you're actually wanting. What you're not asking for is all the additional packages. And that doesn't stay at one package. It quickly blows out into a jungle. So, to give an example, if you install CNCJS into your system, you install that, and that single package, you introduce another 800 odd additional packages into your project. So it's a jungle out there. And looking at the number of packages that are being released, as you can see, the trend is just going up, except for some reason with Ruby gems. People don't like Ruby anymore. So NPN, obviously one of the most popular. There's over 500,000 packages now being released every month, which is huge. So you really have a bit of an efficiency dilemma. You can avoid open source. You can lock everything down, take full control of your code and know exactly what's going in, but that's slow, inefficient, or you can continue to use open source. But of course, the reality is that it's not really a dilemma. The choice has already been made. We're using open source, everybody is. It's obviously the way forward. So it comes now down to choosing what is the right open source, which packages should you be using in your systems. So we do tend to trust open source a lot. And the reasons being is, we assume if it's there open for everybody to look. You can download the source code. But really, when was the last time anybody here actually went in and looked at the source code of the packages that they're using? And, and following on from that is that assumption that if there is an issue, if the source code does have a vulnerability in it, that somebody's going to notice. But who is that somebody? Nobody really is looking. And so we're trusting that this is happening, but it's really not. And so we look then to the scoring mechanisms, the stars, and seeing how other people are rating this package. But the reality is it just is incredibly easy just to clone a package, pick up all the stars, and piggyback on the hard work of somebody else using starjacking just to give yourself a really good rating on a brand new project. So all of these things give that feeling of trustworthiness without actually providing it to us. So the reality is anyone can contribute to open source code, even the attackers. So let's have a look at a couple of examples of when good packages go bad. So this is Faisal Salman. He's from Turkey. He's a good member of the community. He's been working on open source packages for quite a number of years. One of them is UA-Parser.js, which is a part of Node. It's a component that he's developing and has been under active maintenance for over 10 years now. So has 10 million weekly downloads. So it's used by millions. Even Facebook actually uses this particular open source product. So the question is, would you use it? And the answer to that probably is, you probably already are, whether you know it or not. So on the 5th, in 2021, on the 5th of October, Russian hacking underground forum offered offered to sell the credentials of an NPM JS developer account and noted that they didn't have two-factor authentication enabled on that account. And so a couple of weeks later, Faisal started getting bombarded with messages that packages were being released under his, and 3 different packages were pushed out, the versions you can see up here, and they were published into the ecosystem. And looking at this, we can see that it actually downloads a DLL file, which in turn installs a crypto miner on your software. And 10 million monthly downloads. This went out to a lot of different users, and you've got to wonder how much crypto these guys managed to generate for themselves. And of course, they picked a crypto that is untraceable, went into their wallet, and they probably made quite a lot of money out of that. So 2 weeks later, in the 4th of November, we had 2 more packages, NPM packages, compromised. So it was COA and RC, completely unrelated packages being pushed out, being developed by unrelated teams. Total of 22 million weekly downloads for these 2 packages. And looking into it, we actually found that they had the same malicious code had been published into both of these repositories. So pretty sure that it was the same person or group that had actually done this, but nobody to this day knows exactly how they were able to compromise those packages. So in the course of just 1 month, 3 packages with millions of downloads weekly were compromised and put out into the wild. So we're just seeing more and more attacks. It's such a weak point. You can insist that your developers use two-factor authentication on their repositories, but can you insist that the people developing the packages that you use implement those same protections, that they're practicing good security practices on what is essentially a hobby? So those are 2 cases where people actually had their repositories hacked, and it was malicious actors taking over good packages. But now we're going to have a look at Brandon Miller. You might not recognise the name, but you'll probably recognise this particular story. He's another good member of good standing in the open source community. He's making a positive impact. So he had nearly 40 packages, or 41 packages, that he was actively working on, including Node IPC. He'd been maintaining that for over 8 years. And 1 million weekly downloads, so obviously a very popular project. And again, you're most likely using it with that sort of use, out there. So in March this year, he decided to add a bit of new functionality into his code here. And when you dig into it, you can see he wasn't very keen for us to know exactly what he was doing. A lot of base 64 in there. He didn't want just the casual viewer to see what was going on, but he also was obviously trying to hide it from automated scanning tools. So once we decrypted it and had a look at what's going on, the first thing that really jumps out is that we've got an IP location lookup going on here, which unsurprisingly will give you the country that the IP address calling the code is coming from. And then if you happen to be in Russia or Belarus, he decides that you really don't need your files anymore and decides to remove them from your system. And so before you get your documents and afterwards you just get a little love heart. We could ask why, but we really don't need to. It's pretty obvious. So with the Ukraine war having started just a couple of weeks beforehand, this was his way of saying that he's not very happy with the Russia and Belarus at that time. And his answer when he was questioned about this is, it's my software. I wrote it, it's mine. If you want to use it, it's at your own risk and I can do what I like with it. And that was his general activism. And so obviously that's where hacktivism or protestware first started up. This was the first example out there. And so, he was just, it's my code. It's, I do what I want. And there's a lot of pushback, a lot of comments out there, thanks for warning us that, that's the attitude that some of these developers have, that, they can do what they want with their code. So the big question now is, what about his other projects? He did this to one of them, but there's 40 more packages out there. What happens if his next cause is environmentalism and he decides that he doesn't like big banks or whatever, and he just decides that he's going to start attacking other particular causes? Do you want to trust them? Do you want to trust that there's no other little surprises out there? So you really need to have a think about what these guys are, and where they stand. Now, those were two cases where we're looking at somebody spoiling their own packages or being hacked, but there's some actually much bigger players in the industry. So this was one that we've had a research team based out of Israel doing a lot of our work on looking at open source, doing their scanning, and this is where our products come into it. And they found what we call Red Lily. So it's a supply chain threat actor, and they're publishing up to 1,500 malicious packages in a month to the NPM. And they're managing to do this by building custom infrastructure and using specific tools. So normally accounts would, you'd have one or two accounts publishing all the malicious code up into there. So once you've identified a bad package, you can quickly and easily just remove everything by that user. These guys were able to defeat the two-factor authentication used when you're creating a new NPM account, so that every single package was created under a different user account. And then they also used its disposable domains, so that exfiltration was not going to a single domain. You couldn't just use a pattern recognition to say every package that included this URL, just to remove it. And obviously that creates a big cat and mouse game. So, whack-a-mole, every one that we try to get removed, there's 10 more in there that we're trying to get back. Since I put these slides were put together, we've also started becoming rather annoyed with us and started including text files with messages in there directed to the people trying to take them down, like don't look here and, F you and all sorts of stuff in there. So we have a website, redlily.info. So you can see on here all of the different packages that they've published. You can see the relationship between the different packages, the user accounts, and the exfiltration URLs. And by clicking into each one, you can get specific details on the packages and the user accounts that created it and so on. So that's at redlily.info. Anyone interested can jump on there and have a look. Okay, so what are the solutions? Well, the first piece of the puzzle, the answer is software composition analysis, or SCA, which most of you are probably already using. So we can use this to align the security in your operations. So you can frame the conversation around the which packages you're using, the licensing, look at which version you're up to and which ones need to be updated. We can also look at the code itself to see where you're calling it and identify whether or not you're actually calling the vulnerable methods. Using the dashboards, you can actually open your risk profile So you can get accurate on open source library detection, not just on the primary, but also on the transitive packages that are being used, so that you can get a full listing and identify exactly where it is. So if you identify that the UA parser.js is within your base, you can actually see which package it's a part of, so that you know which one, where you need to update everything. And once you've scanned it once, if there's a new vulnerability detected, we can alert you directly, so that you don't have to continually scan your code. As as alerts are issued, we can actually be proactive about it. And then, of course, triage your scan results. You can see an example here of how a transitive package has been identified as problematic, and we can see how the chain of packages that are being used, so you can identify where those changes need to be made. And this is the exploitable path. That's as I was mentioning before, identifying exactly where in your code that these packages are being called and which particular methods are being called. This is really good when you've got we saw it with log4j, so that users could actually identify where they're actually calling the log4j, and also whether or not they're calling the exploitable, the vulnerable methods within log4j. So that way they could identify which ones need to be a priority to look at, instead of trying to deal with everything at once. But vulnerable code, it doesn't equal malicious. So if you've got a piece of open source software in your package that are being used that is vulnerable, you can have a look at it. You can decide at how vulnerable, whether or not you actually have an issue within your system, and whether and look at how you're going to triage and remediate that problem. What you're never going to be okay with is actually having outright malicious. Nobody wants a crypto miner in there being run in their systems. So the big thing is, don't take code from strangers. You got to have a look at it and see what you're getting. So that's where we take this to the next level with our supply chain security. We're all used to the first areas. We're looking at managing your OSS, the visibility, prioritizing what matters. These are things you're probably already doing. What we're looking at now is taking it into the supply chain security. We're actually actively scanning our open source repositories. We're using machine learning and fingerprinting to identify packages out there in the major repositories that are possibly malicious. We can then give them off to the dedicated team who actually investigate that directly. Obviously, the tools can only take you so far. We run that through detonation chambers to see exactly what it's doing in real time, as opposed to just using static analysis. And then once we identify that, we're able to update our databases, as well as alerting the package owners and the repositories to make sure that they're aware. So, some of the things that we're looking for is, outright malicious. We're looking at starjacking, where you're actually, stealing the stars from another package to make yours look a lot better. Where we're looking at, is typo squatting, which obviously we've all been seeing with URLs for decades now, but now we're obviously seeing this with packages. Looking into it, this is the UA parser.js, which we've been talking about. So this is what we get within the actual scanning product. So you can see here, it's assigned up. We've got the policies in there, so the thresholds can be. You can fail your pipelines based on the policy violations. You can see there the management of the risks and what you want to do with it. And we can see here the list of risks. You'll notice there all of the risks listed start with a CX, because they're Checkmarx identified risks in there. So not part of the common vulnerability databases. These are things that we've identified and documented ourselves. Clicking into it, there's a bit more information for the developer. So when they're actually looking in to see exactly why this was marked as a crypto miner, we can see this just gives the person a little, especially the less, the management who have a little bit less understanding exactly why this is being identified as a risk. And the same thing here for the harmful file downloads. Okay, well, we have a stand outside. If you're interested in learning a bit more in seeing this in action, I'm more than happy to do a full demonstration of the actual product in action. Please come and see me. And I'm guessing you'd like to have some lunch. Not quite? Oh, I'm sorry. I thought it was.